Rigid motion transformation means movement of an object. In this example, trapezoid's length, side length KL is 2 units. So after you move the trapezoid, after you rotate it, KL is still going to be 2 units. Just because you move something doesn't mean it's changing size. The only way it's going to change its size is when you dilate by a factor other than 1. So the answer to question number 1 is 2. Make sure you don't put units in the box. Just write down 2. Okay, because otherwise computer will not accept that answer. Example 2, question 2. Here we also doing a transformation. We're going to look for dilation here. Is this dilated? Translated, it's only translated 4 units up and 6 units left, which means it preserves the same size. So you can actually say that ST and S prime T prime is identical. Okay, it's the same side. You're basically just talking about this somewhere translated. Now, ST is shorter than S prime T prime. No, they're the same sides. So that's a no-go. Okay, and we're looking for true ones. Side UT is the same length as T prime S prime. So I'm going to say UT is this long one, the hypotenuse, and TS is that one. So it's not, they're not the same. And last one, side US is the same length as side U prime S prime, and that is correct. So C is the only choice for question 2. Question 3 is my favorite problem. Here we're looking at 2 triangles and additionally 1 90-degree angle. You know the sum of all angles in any triangle is 180 degrees. So first we're going to solve for the, I call it triangle A and then triangle B. So first solve in triangle A. So you can see, we can find this angle right here. Okay, I'm going to call this little guy A. So you know that 180 minus 35 minus 91 is going to give you A, which this little guy right here is 180 minus 35 minus 91. I believe it is 180 minus 126, which is 54 degrees. So this guy is 54. Now, looking at a 90-degree angle, you know that for step 2, to find little guy B, okay, now we're looking at triangle B, you gotta go, this is 54, and this entire angle is 90. So to find the little guy is going to be 90 minus 54, and it is 36. So this angle right here is 36. Now, adding 36 to 84 and subtracting all that from 180 will give us this little guy right here, this last angle. So 36 plus 84 equals 120. So to find the question mark equals 180 minus 120, the answer is 60. So you write down 60 degrees, and notice that the sign is already here, so you don't need to put the degree sign. Okay. Next example, next question. Triangle JKL is rotated 180 degrees about the origin. Again, it's a rotation, so both of these triangles are congruent. Side JK is congruent to side L prime K prime. So JK is this one, L prime K prime is the larger one. So that's a no-go. Side JK is congruent to side J prime K prime. I would say yes. B is good. JK and JK, is that the same? Side JK LOL, no comment there. Side JL is parallel to side J prime L prime. So JL is this side, and it actually is parallel to J prime L prime because they both have the same slope. Look at the slope, -2 over 2, okay? And this one also 1, 2, so it's negative 2 over 2. So the slope of this one is negative 1, and the slope of this one is negative 1 as well. So yes. Now in example 5, we're given a rectangle ABCD. AD is parallel to side BC, and AB is parallel to CD. So, this is how you write down the sides are parallel. You draw the arrows pointing in the same direction. If it's single arrows, that means these two sides are parallel. And in this case, I'm going to write down double arrows to let you know that these two sides are parallel. And look at the transformations. It's translated 10, so translation, reflection, and then rotation. All of this are, again, rigid motion. You know what that means? That spells to me congruent. Both of these are congruent. So basically, A, B, and A prime, B prime are going to be identical, congruent sides, and so the shape is not going to be altered in any way. So let's choose the false statements. So if a statement is true, you're going to disregard it. AB is parallel to DC. Here's my AB parallel to DC. That statement is true, so we are disregarding that because it's given to us in the description. A prime B prime, A prime B prime, it's also going to be like that one, is parallel to side AD. They're not parallel, they're perpendicular. So yes, this is a false statement. Next statement is AD is parallel to AB. AD is parallel to AB, and they're not parallel, they are perpendicular as well, so this is a false statement. That's what we need. And finally, BC is parallel to AD. That is a true statement, so we don't need that. We need the false statements. Example 6. For number 6, given triangle ABC, and we're going to find out the true statements. So statement A, triangle ABC is reflected across y-axis, so once you reflect it, there goes your image, and then reflected across x-axis, so it's going to have to go and face down. That is correct. It matches our image. Say that's correct. Option B, triangle ABC is reflected across the x-axis, so we're going to go count 1, 2, 3. 1, 2, 3, and this one is going to be something like that. And then, so first, second, then this one is going to be first, second, and yes, it does match, so triangle B is good. Triangle ABC is reflected over y-axis and then translated 4 units up. So that means you're going to go up and your image is going to be somewhere right here, and that is not okay. And finally, triangle ABC is rotated 180 degrees about the origin. That means it's gonna go, and if you perform the rotation, the answer is yes, that is correct. So I'm not gonna do that here. Example 7. Given the two congruent triangles, which segments must be congruent? Now, in this particular example, the tick marks is a giveaway. All right. So basically, let's check. Let's go through answers. AB and BC. AB is the one has 1 tick mark. It's the largest side. And BC has 2 tick marks at the same triangle. No, they're not congruent. Congruent means the same length of sides. Now, AC and QR. Let's check it out. AC has 3 tick marks, and QR has 3 tick marks. Also, it lies against the angle with 2 circles here, right? And this one also. So yes, this is good. B is correct answer. SR and QR. Where is SR is here, QR is there? No, they're not the same. And SC and AR. SC is actually this line right here. It's not even given to us, and AR is the long one, so it's obviously not. The only answer is B. Number 8. We need to write down the coordinate of W prime after this quadrilateral has been reflected over y-axis. This is the y-axis right here. So we need to reflect it. And here's how it's going to look like once it's reflected. And notice that 1, 2, 3, 4, 1, 2, 3, 4. Here you go. And this is how it looks like a little butterfly. Now, W did not move. So the coordinate for W and W prime is the same. So it's going to be 0 units on the x-axis. It's going to be 0, comma, -2, 2 units down. And again, when you're inputting that, notice that the parentheses are already placed in here. So all you got to type in your system is 0, comma, -2, done. In number 9, basically what you need to do is, since the scale factor is 3, that's where you change the shape of a change the size of a shape. So we need to multiply every single vertex or point here by 3. So for example, we try multiplying this point, the first one, by 3. -1 times 3 is -3, and -6 times 3 is -18. And none of them are matching it. So far, we don't know what it is. Now, next one. 0 times 3 is 0. 2 times 3 is 6. So my point is 0, comma, 6. And it's right here. It's the option A, E. And next one is 5 and 5. Both 5s. 5 times 3 is 15. 5 times 3 is 15. So my next point has to be 15, comma, 15. And I look at my answer choices. It's D. The other 3 are not part of the solution. Question 10. Pick one which is true about the given quadrilaterals. This is the pre-image turned into the image right here. So you go from small to large. It's an enlargement. Okay, so we know it's dilation. But what is the scale factor? And evidently both of these are similar. Okay, so they're similar. But let's see the factor of dilation, the scale factor of dilation. So looks like, let's compare these sides together first. This side is CB, and this side is C prime B prime. So notice that you go from 1 to 2. So it became twice as large. I want to check out all the other sides. So, and this side, 1, 2, 3, 4, 5, 6, 7, 8. And this side was 4. So from 4 to 8, again, it's 2. Dilation of 2, which option is that? Option C. Similar because it's a dilation of 2 of about the origin with a scale factor of 2. Next example. Which of the following is true? Select all that apply. Now, this is just formulas here. Complementary angles are congruent. That is false because complementary angles add up to 90. They don't necessarily have to be congruent. So they're not congruent. Supplementary angles are congruent. Again, can be true. In our case, it's not. Alternate interior angles are congruent. Yes, always. Alternate exterior angles are congruent. Always. And corresponding angles are congruent. They are the same angles, and they are congruent angles. Yes. Number 12 is a really tough problem. It's given to you as a graph of a line. Graph of a line, and the second equation, the second relationship, is so relationship Z is given to you, and the relationship Q is given to you by a represented by a function or equation, y equals 1/2 x. So we must graph it. 1/2 x. So it's gonna go through 0, 0, but it's gonna go 1/2. That's the slope, and that's where it's going to be. So this is our new equation. I'm gonna make sure it's all extending there. So I'm gonna label that as the Q, and this one is the Z. So let's figure out what's going on. Which of the following is true? Rate of change of Z is 4 times greater than the rate of change of Q. Okay, so what does that mean? That means that Z is 4 times as fast as Q at every given point. And let's just compare. At this particular one, 1 and 4, it is true. What about in this case? Looks like this is about half and this is 2. So half 2 divided by 4 is 1/2. So looks like it's a true statement. Yes. Both z and q have the same rate of change. Slopes are the same. Clearly not. Both graphs pass through the origin 0, 0, and that is correct. And finally, relationship q is increasing slower than relationship z. This is actually, the slope is actually also a speed. So the steeper the slope is, the faster it's going. And this one is slow. So yes, that is correct. Okay. Now, example 13, question 13. Given the proportional relationship y equals 2 over 5x, what value of y could complete the table below? Again, all we got to do here is take this 20 and plug it into here. So we're going to write down this y equals 2 over 5 times 20. This is the values of x. So y equals, and 20 and 5 cancel out to be, this is 1, this is 4. 2 times 4 is 8. So the answer is 8. Just plug in, just write down 8. Next question. Consider the line shown on the graph. Choose the slope of a line. Okay, again, I see a good point here. I see a good point there. Going 1, 2. So it's 2 up and 1, 2, 3, 3 across. So it's going to be 2 over 3. Let's see. And that's the option D. In question 15, choose the y-intercept or B of the line. Now, in this case, we don't need to choose a point. B is a point. Okay, y-intercept is a point. It's got to be just a number. And let's go -1, -2, -3. So this looks like this is a -3, point -3. And that's our choice right here. Example, question 16, consider the line shown on the graph. Ooh, okay, and choose the equation written in the slope-intercept form. So it's the same equation we dealt with. In question 14, we know that the slope was 2 over 3, and from previous question, from question 15, we know that y-intercept is -3. So now we just need to compile it. Y equals mx plus b. Y equals, instead of m, I'm writing down 2 over 3x. Instead of b, I'm writing -3. So I'm just saying which one of these matches. And not A, not this one, not this one. So it's either 3 over 2 or 2 over 3, and we just chose it's 2 over 3. So E is your choice. Next two questions, I'm going to show you a little trick how to find m very easily. So you know that slope is rise over run. Or simply put, change of y over change of x. So we need to find out what the change of y is and what change of x is. Pick any 2 points, any 2 entries basically. So from 0 to 1, what is the, what did you do here? From 0 to 1, you increase by 1, so it's +1 on the x side. On the y side, it's from 2 to 4. That means you jumped +2 units. So again, just divide y by x. So y was, change of y was 2, change of x was 1. 2 over 1, here's how you write it down, 2. Enter the rate of change of this function, m equals 2. Please do not write m equals 2 in this box. The computer will not read it properly. So just write down 2. And last question, The table of values represents a linear function. It's the same function. So enter the equation that represents the function defined by this table of values. So again, we know already that m equals 2. And now we just need the y-intercept, or b. Here's a trick. Every time x is 0, that's going to be your y-intercept. You always look for point 0, comma something. In our case, we got lucky. It's 2. And so b equals 2 as well. So here's what you write down. You don't write down y equals something. Y equals is already pre-written here. So you just write down 2x plus 2. That's all that needs to be in the box. Now, if you don't like this method, for example, this point wasn't given to us. This is a bonus feature right now. So you can you can stop the video here, but bonus feature. So hypothetically speaking, you don't know that this point existed. And you know the slope is 2, though. You know your slope. How do you find b? So to find b, the bonus material here that you guys get is you go y equals mx plus b. You know the slope is 2, so y equals 2x plus b. Then pick any point. I choose this point. So x is 1, y is 4. Instead of y, guess what we're going to write down? 4. 4 equals 2, and x is 1 times 1 plus b. So 4 equals 2 plus b. Now we got to solve it for b. Subtract 2 from both sides. 4 minus 2 is 2 equals b, or simply put, b equals 2. That's how you get b equals 2 in here, and there goes your equation. And that's it.